Hello, YouTube. First of all, I'd like to apologize for being gone so long, but life got busy. I just didn't have time to make any videos. But anyway, here is the Type 503 that I made a video about a year ago, and just like to give some updates to what's been going on with it. To be honest, not a whole lot has been going on with this oscilloscope since I made the initial video, except for one thing. After that video, this oscilloscope started having a very strange problem, where after about 20 minutes or so, the trace would just drift off of the screen and vanish altogether. One day, while I was troubleshooting it to figure out that problem, I discovered that this tube, which in the previous video I had called a horizontal output tube, which turns out not to be. This is more or less like a switching tube, kind of like a switching transistor in a switch mode power supply. I noticed it was red plating. And to that I immediately turned it off and started investigating on the schematic of what could be causing this tube to red plate, and if it was related to the problem that I was having with the trace disappearing. Before I move on to what I found, I noticed that when the trace disappeared on the screen, this tube in this shock-mounted socket, the filaments were out while the problem was occurring. And there's an identical tube on the opposite side that did the same thing, which I presumed the two filaments were most likely connected together. So I took a look at the schematic and found that those two tubes are connected. It's these two filaments right here on this 12-volt rail coming off of the main, what I guess you could call a switching transformer. And so I started looking at the regulation circuitry, see if maybe that could cause the problem, because this appears to be supplying most of the scope with power. So upon checking all the components around the main tube, I found that this resistor, I believe, I discovered that, quite by accident, that it was temperature sensitive. I could cool it down with some freezer spray and the resistance would drop, and heat it up with a soldering iron and the resistance would go up. And then soon after, I found this capacitor that looked quite nasty and just looked bad. It just looked like it had been getting pretty hot. So I replaced both the capacitor and the resistor, and that solved the problem. So now let's turn this oscilloscope around to the other side and show you where exactly the capacitor and resistor are located. So here is the other side. This is the other shock-mounted tube, and the resistor and capacitor exists in this corner over here. I'll reposition the camera for a closer look. Here is the bottom side of the switching tube, and here are the capacitor and resistor. And I think what had happened is, over time, this resistor was heating and cooling, and thus frying this capacitor, and eventually the capacitor failed, leading to higher current draw in the circuit, and then eventually, due to some unknown stress, perhaps caused by this bad capacitor, caused the resistor to fail. And then eventually leading to the switching tube to red plate. in conclusion, that was a very interesting and definitely educational experience. It definitely proves what a lot of people say about vintage equipment, and that is, if you're going to be using them for any length of time, you need to change all the capacitors and check for any bad resistors, because if you don't, it could just up and start failing. And I feel like I was pretty lucky with this, because it was a pretty obvious problem, and I caught it early before it did any serious damage, because that could have either fried the switching tube, or if worse come to worse, it could have fried the transformer, which could be a hard part to locate, since Tektronix made all of their own transformers. So I hope you found this video interesting, and I will catch you next time.